Welcome to my channel. So in this video we are going to see the topic introduction to signals and system. Okay, so in this under this topic we are going to see the three things. One is what is the definition of signals and what is the definition of a system, and another one is we are going to discuss the standard signals used in our communication and signals thing. Okay, so what are the standard signals we are going to study? Okay, these are all the three topics we are going to discuss. Okay, so first one, you see the definition of signals. So you know signal. Okay, so in our day-to-day life we are using the term, it is called as signal. So but what does mean by signal means? So mathematically the signal, it is described as a function. Okay, it's a function of one or more independent variable. Okay, and also the signal which contains some information. Okay, each signal is having some information. Okay, for example, you take it as a one audio signal. So that audio signal, so it is a function of with respect to time. Okay, it's a function which varies with respect to time, and that audio signal, it is having some information. Okay, their own information. Okay, so that's the thing. So this is the definition of signal. So otherwise the signal, it can be defined as, the signal is said to be it is a physical quantity which contains some information and which is a function of one or more independent variable. Okay, so the signal may be it's a function. So you know the signal, it is said to be the function. So that a function, it will vary with respect to either single variable or two or three independent variables. Okay, so usually, so in our, that is in our electronics field and communication field, so normally we are using the electric voltage, electric current, and the pressure, sound, and the light signals. Okay, so these signals, it is an example for the signals, and these signals which vary with respect to the single variable time. Okay, in some time, if you are taking as an example for image signal, means that image signal, it will vary with respect to some more than two independent variables. Okay, so this is the signals. Okay, it's an important definition. So this is a 2-mark question. So what does mean by signal? So the signal is described, it is a function of one or more independent variable which contains some information. Okay, similarly the signal, it is also defined as, it's a physical quantity which contains some information and which is a function of one or more independent variables. Okay, so the examples for the signals are, you know, the electric voltage, current, and sound signal, audio signal, light signal. These are all the examples of signals. Okay, so the next one, so we are going to see the definition of system. Okay, so system, what is mean by system? So system is nothing but it is a interconnection of some elements or blocks in order to produce their desired output for the given input. Okay, so you take one example. So all these things are said to be in real time, the amplifier, okay, oscillators, and the fan, light. So these are all the systems. Okay, so by in that thing, the amplifier is constructed using some active device, that is either transistor or a FET or MOSFET, with the interconnection of some more resistance and capacitances, and we have to give some input. That amplifier, it processes those input and it produces the desired output. Okay, so that is said to be the system. So amplifier is a very good example for system. So, and the radio, TV. Okay, so in real time we are using different systems in our thing. Okay, day to day life we are using all these things. That the fan is a one simple example for one system. Okay, so fan is having some components that are interconnected together. So for that fan we are applying some input signal. Okay, so what is the input we are applying to the fan? Some AC input is applied, and the fan is giving rotation, that is the mechanical, it produces, it converts the electrical energy into mechanical rotation as a output. Okay, so the mechanical rotation is a output, the electric signal is a input. Okay, so the interconnection of that element, we are calling it as a system. Okay, so the system, it's a set of elements or functional blocks that are connected together and produces an output in response to an input signal. Okay, so this is a one basic block diagram of system. Okay, so in system there are two types of system is that, either continuous time system and discrete time system. Okay, that is what is continuous time system and what is discrete time system means. So for one system, if the input and output signal, okay, so we are giving some input, we are getting some output from the system. Okay, if the input applied to the system and output taken from the system. So both are continuous signal, means that type of system we are calling it as a continuous time system. Okay, so similarly for discrete time system means the input applied is discrete signal x of n, and output we are getting as a output discrete output y of n, means that system it is called as a discrete system. Okay, so the amplifier, it's a very good example. Okay, amplifier and our fan, it's a very good example for continuous time system. Okay, since what is the input applied to the amplifier? The analog signal. Okay, the continuous time signal we are applying as a input. So that's why the amplifier always gets the continuous time signal as an input, and it produces output is also a continuous time signal. So that's why the amplifier is an example for continuous time system. Okay, so that's the thing. And the digital systems, okay, so the digital systems, those are all the discrete time system. Okay, so that's the thing. And so in this diagram, the x of t and x of n. Okay, so the input we are giving the two things, one is x of n, another one is x of t. Okay, what is x of t means? It is a continuous time input. Okay, so always the continuous input, it can be described as a x of t, that is the function x, it will vary with respect to the continuous time variable t. Okay, and the discrete input is always mentioned as x of n. Okay, so in order to differentiate it is a continuous time signal or discrete signal, so we are using the variable, the continuous variable is a t, and the discrete variable it is a n. And you know, there is another one, term for the input. Okay, so the input of the system is otherwise called as excitation. Okay, so the input input, it is otherwise called as excitation. The output y of t and y of n. Okay, this output it is also called as the response of the system. Okay, so the output in this signals and system or our communication and engineering field, we are call it as a output of the system is said to be the response. Input applied to the system, we are calling it as a excitation. Okay, so this is said to be the system. Okay, so I think you understand the system. Okay, what is system? System is nothing but it's an interconnection of some elements or blocks in order to produce the desired output for the given input. Okay, it is a thing. And what are the examples for our system means? So you know, so different thing is that. Okay, amplifier and communication filter, it's a low pass, high pass, or any type of filters. Our TV and transmitters. Okay, radio transmitter, TV transmitter, receiver. These are all the examples for systems. Okay, so that's all the definition of signals and system. Okay, and the next one, so in the signals and system, okay, in this paper